Welcome to next video in Edexcel A-level functions, which will be video number 3, and we're going to talk about composite and inverse functions. Composite function is the first thing I'm going to talk about. And guys, composite, as the name suggests, this is the combination of two functions, or combination of more than two functions as well. Okay then. This is a question from past exam paper. Fx is 2x plus ln 2. Let's understand the notation. This is x belongs to real number, becomes the domain of the function. That means the all real numbers is the domain. And second function is an exponential function, is to the power 2x. And they've asked me to find g of x. Okay, in some books it will be written as just gf, or in some old books I've seen this written g of f as well. It all means the same thing. What do we need to do for composite functions, guys? We have to put f into g. Right, let me say it again. We're going to put f into g. What I ask you people to do, just write down g there, and instead of x now, write down the fx. And what is the value of fx in this case? 2x plus ln 2. Right, now you're going to put that bit in the g function wherever you see the x. Right, so the answer would be e to the power stays as it is, 2 stays as it is, and instead of x we write what? 2x plus ln 2. Right, with your previous knowledge of exponential functions, I would advise you to start working on this yourself, see what the answer is. I'll show you that after you've done. Okay, then let me run you through with this question. So this will be from here, it comes out as e to the power 4x plus 2 ln 2. Okay, now we've done this quite a lot in the first year course. Okay, if there's two powers are added and I have to separate these two terms, this will be e to the power 4x and times e to the power 2 ln 2. You can write this as ln 2 square as well. So e to the power ln 4. What happens here, guys? This term stays as it is, and you know your e and ln are inverse processes. They cancel each other, left with 4. So the answer is 4e to the power 4x. So this is g of fx. I'll give you a couple of seconds to have a look at it again. Okay, we work on it now. Let's find out the function in the other order. If we have to find fg, that means I need to substitute g into f. Follow the same process, write down f and then put a bracket in there. Don't write any x in there. What do you write instead of x is gx. So now, guys, look at your f function. Wherever your x is on the right side, replace that x with e to the power 2x. So you get 2 e to the power 2x plus ln 2. That will be the answer of fgx. So that clearly tells you, guys, this composite functions are not commutative. G of x is not same as fgx. That means the order does make a difference. Okay. Now, sometimes what they ask you to do is evaluate the composite functions. That means you're going to find gf first, which you've already done. All you need to do after that is substitute x as 3. So the answer would be from here 4 e to the power 4 times 3. So 4 e to the power 12. This is gf function evaluated when x equals 3. Write another extension in here. If they ask you to find the range of g of x, what do you think you'll do first? You will first of all plot the graph. I've done this many times before in my previous videos. I'll do this one more time. E raised to power x is the first graph, then e raised to power 4x, okay, then 4 times of that. E raised to power 4x will do what? It will squeeze the graph in. That means x going to be divided by 4. That stays 0 here, 0, 1, so then it becomes 0, 4 there. So range is g of fx is greater than or equal to 0. Okay, I mean, obviously you can use your knowledge to work out the range and domain of these functions. Another variation in this is sometimes, rarely though, they ask you to find composite of 3 functions. Nothing changes, guys, here. You just do put f into g first to find gf, which you've already done over here. Then you put that gf into h. So h function is there. So in this case, we'll do what? H, then bracket the gf of that. Then wherever I see x in the right side of h function, put that in here. So it will be 2 times 4 e raised to power 4x plus 5. So final answer of hgf will be 8 e raised to power 4x plus 5. Right, this is the variation in the composite functions. Then they can ask you to solve equations, and that should be straightforward algebra. We move on now to inverse functions. Right, in my normal mapping diagram, if I say f is a function from x to y, so f is a function from x to y, or we just write down y equals f of x. Okay, so every element of the domain set of x has a unique range in the range set. Okay, but then if we try to do a mapping of this in the reverse order, that means we say f something is a function of from y to x. Okay, that is the inverse function of x. We rate says f to the power minus 1x, like sine inverse, cos inverse you've seen in trigonometry before. Okay, so inverse functions is a function from y to x. So this was the domain set for the normal function, and that was the range set for the normal function. If you look at this diagram carefully, so this range set will become domain from the inverse function, and range for this domain set of the original function will become range for the inverse function. Very important property, so guys, and you got to understand this very carefully, with some exceptions, some restrictions at times, but generally speaking, a domain of the original function becomes range set of the inverse function, and range of the original function becomes a domain set of the inverse function. And one more very important point, guys, if you want to represent these graphically, really important that you understand this. F inverse is F inverse x is a reflection of fx in the line y equals x. I'm going to show you this with a couple of examples now. All right, I have discussed this many times in this functions unit before. This is a graph of y equals e to the power x. This is the line y equals x. You know your basic reflection, people. If I want to reflect this graph in this line, it will come like this. And this will be 1, that 1 will be here. And guys, this is the graph of y equals ln x. And this is what I meant when I said, I've been speaking here already, that e and ln are inverse functions of each other. So this is how inverse functions look. They are reflections of the normal function into line y equals x. And now I'm going to teach you how do we actually find inverse functions using algebra. Okay, so this is a question like question number 7 in the exercise 2C of 2D of the book. Okay, and we're going to find the inverse function. Guys, the step 1 is you're going to be writing this as normal y and x notation if you can. And now, really important, what I would advise you to do, people, make x the subject. Okay, I give you time to work that yourself and your GCSE knowledge, algebra of first year, and make x the subject. So after doing your normal basic algebra, we got to this stage where x is the subject. So guys, we rewrite this now. The f inverse x is equal to same thing, but change y into x. So it'll be 4x plus 5 over x minus 3. Okay, just have a look at it for a minute, then I'll explain to you further more things in this domain and range. Now, this is really important that you understand this now. What I've done using my graphical calculator, I've drawn the graph of y equals 3x plus 5 divided by x minus 4, and I can see this function is clearly defined on every value of x except x equals 4, and you can see it from here as well. The domain, this function, because it's a fraction, will not be defined when denominator becomes 0, so its domain is x is all real numbers, but x cannot be equal to 4. Okay, because graph does not exist at that point when x equals 4. Now check the range for this, people. Range is how high or low graph can go. So graph can go as high as it wants, as low as it wants, but very important, can never be y equals 3. So range for this function is range fx is all real numbers, but fx cannot be equal to 3. Okay, because you can see graph never doesn't have a value of y equals 3. Really important to understand, people, from here. If you try to find the domain of this inverse function, it's a fraction again, and fraction will not be defined when denominator is equal to 0. So domain is x belongs to all real numbers and x cannot equal to 3. So try and understand that domain of the inverse function is come out same as the range of the normal function. Right, this is the example, this is a demonstration of this rule which you need to know. Majority of the times, with few exceptions, with few restrictions, domain of the inverse function is same as the range of the normal function, and sometimes this is used to find out the range of the normal function. When we cannot plot the graphs, we find inverse and you find its domain, because that's easier. That will be same as the range of the normal function. Once again, to find the range of the normal function, what you can do is find the inverse function and see what its domain is, and that will become the range of the normal function fx. Right, so to end, I'm going to talk about question number 12 on the exercise 2D. So that's a function given to you. It says show that this function can be written as this. That's basic algebra of your first chapter of this book. So how do we multiply, subtract two algebraic fractions, find the common denominator and stuff, you know that. Then comes find the range of f. Now guys, range of f is, because this is a function, it's not very difficult to draw a graph. So it's 1 over x is the graph first, okay, then x changes to x plus 5, that means graph shifts 5 units to the left. You can find the range of that. Then says find f inverse x. You use algebra, make x the subject from here, and domain of the inverse function. Most likely that domain of the inverse function would be same as the range of the normal function. With that, we've finished this video, and in the worksheet I've given you links of a lot of past exam papers on the internet, compiled by different providers. You can work on those questions. If there's any issue, you can write an email to me and we'll give you solutions, detailed solution of that particular question. Bye bye, enjoy learning.